Hi guys, and welcome to this further math video on problems involving simultaneous equations. Yes, it's building on the previous videos we've recorded for this course, which can be found on MaffsGuru.com. Yes, I am Darren, otherwise known as MaffsGuru, and it's really good to see you. Yes, MaffsGuru.com is where you can find all of these videos where there are downloadable notes, there are exam-style questions from VCAR. The videos are all sort of organized by textbook, and there's so much more to come. So head over there, it's free to sign up. And if you can do me the honor of subscribing on YouTube, we'll be deeply grateful as well. Why? Because I'm never going to be rich, and I'm certainly never going to be famous. Who watches videos on YouTube? Well, lots of people, but not maths videos. Yeah, just subscribing lets me know that you are out there. This learning objective is to apply the knowledge of how to solve simultaneous equations using the following methods. Now, substitution, elimination, and CAS. This is actually a CAS course, so on the whole, we're going to use a CAS for these particular examples. Yes, but it's nice to know that there is a video out there, previous videos, in fact, showing you how to do substitution and elimination. Now, in our previous videos, if you haven't watched it, you can watch it on MaffsGuru, watch it on YouTube. We looked at the idea of how to use the CAS to solve simultaneous equations. And we came up with the idea that effectively simultaneous equations were nothing more than straight line graphs that crossed in a certain point. And generally speaking, where they cross is a solution to something we're looking for. Now, in previous years, in year 10 or what have you, we just made you do it for the sake of doing it. You did it by pencil and paper, you did it in all sorts of different ways. But in further maths, you've used matrices to solve them, CAS, linear equations, blah, 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 blah. And as I said in a previous video, we could either solve it graphically, which is what's happened here. We put the two equations that we had in, and we had a graph. We looked at the intersection point, and we found out where the graph intersected. Or we put the two equations into our sort of linear equation solver, and again, out come the value. And interpreting what that value means is incredibly important. Please don't underestimate the importance there of the values of what's coming out. So, as it's a CAS course, I said here we're going to use the CAS, all right? Yes, you can do pencil and paper method if you want to, and maybe stretch yourself. For those of you out there who want the 50s and the highest exam scores, have a go at doing this by pencil and paper as well. But I'm going to use the Casio ClassPad, which is my calculator of choice at the moment. Used to love the TI Inspire, but the Casio, I think for many of the things that I do, is much simpler. So let's break an example down into stages. And these examples are taken from the Cambridge Further Maths textbook. And thank you very much to Cambridge for allowing me to use your examples. Gratefully appreciated. There are two possible methods for paying gas bills, method A and method B. Now, the thing I'm looking at here is they've given me two methods, which ultimately means there's going to be two equations I can get out of this stuff. Determine the number of units that must be used before method B becomes cheaper than method A. This is screaming at me, draw a graph, find the equations, and work out which graph is cheaper or better at particular points. So method A fixed charge of $25 per quarter. If you remember from a previous video, fixed charge is really just my intercept, plus 50 cents per unit gas used. Okay, that sounds like a gradient to me. Method B, a fixed charge of $50 per quarter, ouch, plus 25 cents per unit of gas used. So that's got an initial or a higher initial charge, but less for the gas. The other one has a lower initial charge, more for the gas, and this is how they sting you every single time. All right, so let's look at creating equation 1 from method A. So we know the cost of my gas, and let's call it cost, and let's call it cost 1, is equal to, and we know that a fixed charge is a payment that I'm just going to have to pay, which is $25 plus 50 cents. Now, again, notice the difference here in units. One's in dollars, one's in cents. So we have to put 0.5 and times, let's call it, I don't know, let's call it X, where we're going to define X to be the units of gas, all right? So that's per unit of gas. Right, awesome. C1 equals 25 plus 0.5. So let's write that slightly nicer. C1 is equal to 25 plus 0.5x. Thank you very much. Now, the units of gas for method A and method B are going to be the same. So actually, I can use the same variable in my next equation stand for gas, but not my cost. So let's look at equation 2. So we have the fixed charge. So now we've got C2 in this situation is going to be 50, because that's my standing charge, that's my fixed cost, plus 0.25 times x. Or, writing that slightly nicer with that times sign on, 50 plus 0.25x. I have the two equations with two unknowns. I see 3 unknowns. How are we going to solve this? Well, the cost is the cost is the cost. And our graph, fabulously, or our calculators can do this for us. So, as you can see here, now, there are my two equations. C1 is 25 plus 0.5x. C2 is equal to 50 plus 0.25. But the point of it is, they're both costs. So, we are going to have cost up the side of my axis here, and we're going to have the units of gas along the bottom, which we're going to call the value of x, and let's call this the value of c. Now, putting these into my graph section of my calculator and plotting them, what do you notice? Well, I've got a red line and a blue line. Yay! Whoopee, whoopee, whoopee do. But what does that actually mean? Well, analyzing these graphs is really, really important. So, drawing them out, we've got this blue graph that seems to go up. And then we have the red graph, and sorry guys, I can't change my colors, that seems to have a much less steep gradient. So this point here, where they cross, is really, really important. Let's just analyze what that point there means. There's the cost, and there's my units of gas. That point there tells me that for both method A and method B, the units of gas and the cost are exactly the same. So at this point here, whatever that unit of gas works out to be is the same cost for both method A and method B. After that point, and before that point, we need to look and see what's happened. So initially, let's look at this one here. So this is my blue line here. That suggests that up until this point, the blue line is actually cheaper. So up until that one point there, it is cheaper for the blue line than it is the red line, because the red line's higher, it's costing more. But after this point here, it's actually more expensive to have the blue line than it is to have the red line. So depending on, I think this one was method A and this one here was method B, then what we can see is method B becomes cheaper, right? So method B becomes cheaper after this point here. So we need to find that point on my graph. How do we do that? Well, using the information from our previous graph. How? By using our point of intersection. If we can work out our point of intersection, then what we can see is that for 100 units of gas, it costs $75, right? So for 100 units of gas, it costs $75. And it's after that point, after 100 units of gas, will it actually be cheaper to have method B than it will to have method A. And that's brilliant. So actually taking these two equations, plotting them here in my CAS, finding that point of intersection, and then just trying to work out which graph is higher. Is B higher or is A higher? Because once we know which one's higher, we know which one's cheaper, and then sort of interpreting the question. Example 2, this is a more traditional type of question. 3 kilograms of jam and 2 kilograms of butter cost $29. 6 kilograms of jam and 3 kilograms of butter cost $54. That's very expensive. Find the cost of 1 kilogram of jam and 1 kilogram of butter. Now, in this situation, it seems to be a lot of information. But let's use the letter X to stand for the cost of 1 kilogram of jam. Let's call the Y the 1 kilogram of butter. So what we know is 3 kilograms of jam. So we've got 3 kilograms of jam, which is 3 times X, because X is the cost of 1 kilogram, and, which is plus, 2 kilograms of butter, 2 kilograms of butter, which we're calling Y, costs $29. Okay, so we're relating kilograms and costs, still those two unknowns. What else do we know? We know that 6 kilograms of jam plus 3 kilograms of butter gives me 54. And lo and behold, ladies and gentlemen, voila, we have two simultaneous equations, or a set of simultaneous equations. And what can we do now? Oops, I've jumped section. So basically that was what we were talking about there. That's where I would have got my equations. Let's skip to the next six. Well, next step, we're just going to use my CAS to solve. Again, I don't need to sketch these. I could, if I wanted to put them graphically, wanted to show you a different way of doing it. So basically I have placed these two equations here into my equation solver. Again, remember, we are trying to solve for X and Y, and out comes the value of X as 7 and Y equals 4. What does that actually mean? Well, we then have to interpret the data. So that means X is the cost of 1 kilogram of jam. So therefore, 1 kilogram of jam costs $7, and 1 kilogram of butter costs $4. Et voila. Now, sorry guys, I don't really know what's going on my screen at the moment. I think it's overheating, which isn't particularly good, but we've got the general idea. And there we go, there's my answer. Now, much of what we have to do in further maths, we have to interpret our answer. So the working out is one thing, but then you should really write a formal sentence stating it. And as I say there, hence the jam costs $7 per kilo and the butter costs $4 per kilo. And life is good. Calculator all the way. There we go. Thank you very much for watching. That is just 2 examples. There are so many more examples we could do, but actually it's about you having a go, extracting the information. If you ever get stuck, you can certainly ask me for help. I'll do what I can. Ask your teacher. Ask mum, dad, anyone who has a mathematical brain. But I'm pretty much done. Thank you very much for watching. If you can, subscribe on YouTube, and I'd be deeply grateful. Otherwise, head over to MaffsGuru.com and sign up over there. Or just have a wonderful day. Hopefully see you in another video. Take care. See you again. Bye-bye.